If you click on that, you will be taken to a new window, which is Colab Research window, and it states, welcome to Collaboratory. As a first-time user, you will need to sign in on the platform with your Gmail account. And why we need a sign in on this platform, basically, because it will save all your coding sheets in your Gmail drive. So which makes it easier to access in future anytime. So all your sheets will be precisely saved in your Gmail drive if you sign in with your own Gmail ID over this. So once you sign in, you can open up a new notebook, same as I have on my screen right now on Google Colab platform. On this screen now, what we have, there are two things that we'll be using frequently. One is a code cell, other is a text cell. We'll be using both of them. Text cell, you'll be using to write any of your references, or maybe if you want to create some notes, some headings, etc., that you can create with the help of text cell. And similarly, code cell you can use to write all your coding syntax in Python. So you can just click on this and the cell will be inserted here. You can use the up-down buttons beside this cell to change the order of these cells. So this is the most important thing we'll be using throughout the sheet. So whenever I create notes, if you get confused at how these notes are coming, so they will be coming basically from the text cell. So whatever you have to execute, that you have to put in the coding cell. So is it fine up to this? You can ping me in the chat box anytime if you find any trouble, or even if I ask you any questions, you can put in the chat box so that we can have an interactive session throughout this hour. Everyone ready with the platform, and can we start? You can ping me in the chat box. I would expect some interactions in the chat box to ensure a collaborative session. Great. Thank you so much for responding. This is always good to have an interactive session, because then I will come to know that you people are doing it side by side. So first of all, starting with an overview of your Python platform, and I'll be just telling you a few essential things that you have on syntax part and how you start. So first heading here I'm putting is overview of Python. And you can see I can make them highlighted by using your simple text settings from the top. This bold, italic, and text size changer, all things you will find here. So we can easily create our notes from here. The first most important thing you need to learn how we write comments in Python, because they will help you to create your further notes between the coding cells. So in Python programming, we use hash symbol to write a comment line. You can see when I enter a hash symbol over here, after this, I can write anything which will not be executed by the platform, such as this is a comment line. And on your this Google Colab platform, we have color indications also for everything. So comments usually turn out to be green. You can easily identify them with the green color, that these are non-executable lines. So whenever we have to write a comment, we'll use this hash symbol. Then moving ahead with your first program in Python. And for this, as we have in all programming language, the hello world or hello Python thing we are going to write first of all. So in Python platform, any alphabetical sequence we write with the help of quotation marks that will create your direct string sequence. We need not to declare any type of data over here, because whenever we assign a new thing to the variable, it takes the data type automatically. So we need not to make any prior declarations. So let us see. I'm writing here a simple hello Python syntax within inverted commas. And if I run this, you will see we have a quick execution for this hello Python syntax, and it will be printed in the output. Currently, I'm not saving this inside any variable. I'm just printing it as it is. But of course, you can put it inside a variable, such as I'm writing here a message variable, in which I'm updating this hello Python sequence. And you can see it is now saved in message variable. And we can, of course, print it by using print command. Print command, same as most other programming languages, will help you to get your outcome printed in the by the end of this cell. So this is your first most program in Python platform. There is one more interesting thing to know about this Python platform. We have different types of quotation marks in Python, and they will be used for different purposes. In general, what we prefer is, first of all, whenever you are writing a single word you have to print somewhere, or maybe you are just trying to declare something in single word, we prefer to write it within single quotation marks. Although single and double quotation marks can be used alternatively, but in general, we prefer that single quotation marks are used for single word sequences, such as I can write it in this format over here. Similarly, we can have double quotation marks when we have a sentence, such as I'm writing it here. This is a sentence. And then we can have third for a multi-line statement, or when you have a paragraph. In that case, you need different types of these three quotation marks together. And how we print them usually, you can write them in this sequence. 3 quotation marks in the beginning, such as further we can write, maybe this is a paragraph that contains multiple lines with 3.
Sorry to disturb you, ma'am.
Yes, sir.
Ma'am, can you please start one more tab, and there you can open Snipper, so that everyone can get that link, and they will side by side practice these codes, because
Sure,
it
sir.
is hard to write everyone.
I was planning to put it in the chat box. Should I use Snipper for this?
Ma'am, Snipper is best, ma'am, because everything will be recorded over there.
Okay, fine. So let me just find the link for this. If you can share in the chat box, sir,
Okay,
for Snipper. Yeah.
You continue, ma'am.
Okay, sure. So we have 3 quotation marks to write a multi-line statement. And note that these quotation marks can be single or double type. But make sure whatever you have used in the beginning, the same you have to use by the end. If you are using 3 single quotation marks in the beginning, it should end with 3 single quotation marks only. Or if you start with double, it should end with the double only. So this will ensure you to type a multi-line statement easily. You can see here. So other than this, we can also create a multi-line statement by using backslashes. That is also possible. For instance, if I take the same sequence over here and I print it here, I'm removing these quotation marks, and we can just insert some backslashes over here. That will be, sorry, these ones. We can insert, and you can see the color immediately changed for all these. And this will instantly help you to create a multi-line statement again. And difference also you can see. When we have these connecting slashes, they will bring your line to a single format. However, in this case, they will consider the enter separately and the lines will be printed in this format. Means they will be printed on separate lines, same as you have entered them here. But with a slash, you can connect all points together and they will be printed in sequence. So this is the main difference. I'm just trying to open Snipper side by side. I'll be sharing codes in that. So just wait for a second. So students, I'm updating all the codes in the Snipper also that you will see in the chat box. You can take them from the same window. Okay, fine. So till now we have just understood different writing styles for your string sequences. Now let us have an idea about what are different data types possible in your Python platform and what kind of operations we can conduct on them. Because there are several different techniques you can use for this. We'll be discussing just a few concepts about each one of them. So first category we have is primitive data types in Python. And this basically includes numbers, strings, floats, then we have booleans and complex numbers. So these are important categories that you will find for primitive data types in Python. And let us do a few operations on each one of them. First of all, I'll be just using simple variable declarations for each one of them and we'll just check their data type. So let me create variable 1 is equal to, for instance, 100. This is the integer type variable I'm creating here. A number sequence basically I'm updating. Similarly, variable 2 I'm entering. The one which is within inverted commas will be automatically considered as a string type variable. Then, for instance, we have variable 3 that I'm writing as a float, for instance, and then variable 4, Boolean. As you might be already aware that Boolean sequences are basically in the form of true and false. So, for instance, I'm declaring this variable 4 as true, and you will see this turns out to be a blue color automatically, since this is a reserved keyword in Python. In Python platform, we have plenty of reserved keywords. And when you type them on this Google Colab platform, the color indicates that they are reserved keywords. So accordingly, I'll be also showing you different types of keywords that are already present in Python, and we'll just have a look over them. Currently, we are using one of them. If you write here false also, that will be turning out blue, because that is also a reserved keyword for Booleans. Then we have this variable 5, for example, I write here some complex number. And in case of Python, we use J to represent your complex value. It will not be represented with I, but it considers J for this property. I have declared these 5 variables with their distinguished elements. And you will see here, if I try to check variable type of each one of them, for instance, this sequence I'm using to check data type, you will see that in your Python platform, they are automatically designated as different data types, depending upon what values we have saved inside. See, in sequence, they are getting their original format. Whatever data type we have declared over here, the same we can see in the output. So I'm just putting this also in the snipper and you can get it from there. After this, the next part we have is, we have learned about the different types of variables possible, but along with this, we had to discuss about the keywords that we just had come across here. So there are different types of keywords in Python, and how you can come to know about that, which are those keywords that you can utilize on this Python platform. For this, you may first need to import keywords in Python. Note that in Python platform, whenever you have to use some existing libraries or existing packages, we may sometimes need to import them first. And some packages are also required to be installed because they are not available by default. So whenever we'll be working on different projects further, we'll be using these things time and again. Sometimes we'll install some new packages, sometimes we'll import some existing libraries. So here, one thing we are doing, we are just importing all the keywords that are saved on your Python platform. And in order to do this, I'm just using import command over here. And after import, I have to write about the library or the module that I need to get. After this, we can just get the list of all keywords. For example, I write here keyword dot keyword list. So if I run this particular code, you can see here all the list of keywords that are existing on your Python platform. There is a long list. You all can print it side by side. I'm just sharing this code. And you can see that we can use all these keywords time and again. It is not preferred to use these keywords as variable names. It is better to use variable names other than this because these are already reserved values in your Python. So still you can just have a look on these. And along with this, if you just need to know that how many keywords in total we have, maybe you are not willing to count them all physically over here. So how we can do that? We can just check the length of keywords by using a simple command over here. Length. This len we can use several times in Python. We'll be using this just to check length of certain list or maybe certain tuples, etc. We'll be using this time and again. So you can see here, in total, we have 35 reserved keywords that we can use whenever required. So this length command also I have shared in your chat box now. While working on different data types in Python, you may also need to understand what are different operations that we can conduct on them, because we have already seen that we can declare these many types of data parts here. So when we have to work on certain operations for these, what we can do? Let us start learning some basic operations first of all, such as arithmetic operations in Python. And as you might be already aware, in arithmetics, we generally consider some summation, addition, subtraction, multiplication, division, and many other operators like this. So in every category of these operators, you will find like multiple operators possible there. But we are going to discuss the most important ones over here. So for this, let us create some arithmetic operations. First, I'm declaring some values. Like A, I'm declaring equal to 5, and then B, I'm declaring equal to 2. So these are some variable declarations I'm using, just assigning two values here. After this, maybe I want to conduct the operations such as C is equal to A plus B. This is my simple addition operator. Similarly, we can have A minus B, simple subtraction operator. They will be same as normal mathematical commands that we use several times. Maybe we can have A multiplied by B. This is for your multiplication. And after this, we can have division also. Division in Python is represented with this slash symbol only. So we can write each one of them like this. And in order to print the outcomes, you can simply use the print command. And let us have a look on how we can add some variations in this print command. Earlier, we have used it with these sentences. We have just printed these static sequences. Whatever we have inside inverted commas, they are some static sequences which will be printed as it is. But if you have some variables and whose values you want to print with this print command, how we can utilize them? See here, we have some creative options. For instance, first I want to print sum, and where I have stored my sum value within C. So I can write here C. After a comma, I'm writing the next, which is subtraction. So I can write it with D over here. Whatever I'm writing inside these commas, inverted commas, that will be printed as it is. And these values will take their latest value updated in the operation here. So variable values will be taken from the equation itself. Similarly, for subtraction, it will be updated. Then we can have it for multiplication. So multiplication we have stored in E, and then we can have it for division, and that we have stored in the next value, which is F. So we can print this, and you can see the sequence we got for all the operations there. And if you want to make it more clear, you want to create some separations between the values, we can simply use the simple formatting options. We can add spaces anywhere in the static sequences, like I have added it here. And we can see the values precisely well here. So these are some basic arithmetic operations that we can utilize in your Python platform. You can have many others also, like there are some modulus operations where you need remainder only. You can have floor operators where you can find the results for these divisions precisely. And there are many other things you will find. But the most essential ones I have covered over here. However, sometime maybe you need to create a program where you don't want to give fixed values. Like here I have given A is equal to 5, B is equal to 2. But maybe you need values to be provided by the user every time. How we can do that? So for this, we have another creative operation that we can do with an inbuilt function in your Python platform. Although we are going to discuss functions in detail later on, but just for a quick introduction, we are going to use an input function over here to get user data. And how this will be working? For instance, I'll be using input function, and here I'm writing enter first number. This will just ask user to enter the first number, and that will be saved in X automatically. Similarly, I can update this one in Y sequence, and we can have the second number updated here. After this, we can have the operations one by one. For instance, I want to create sum of X and Y, and that I want to get with X plus Y. See this, even if you want to do the calculation part within print statement, that is also possible. Maybe you don't want to assign a new variable for this. You can do the calculation within print command. So this is a very friendly language you will find. You can easily update these values. Similarly, we can have it for other operations, like we can write subtraction of X and Y. I can add the minus sign here. The static sequences you can update as per your choice. You can write anything as per your required operation. We just need to update the symbols and we can have the outcome over here. Last one is for your division, and the symbol I can update here. And if you use this input sequence, you will see one important thing. Let me mention it clearly. If I execute this program like this, what we will have is, it will not be like an original addition or arithmetic operation. Why? Because there is an important concept to learn. Input function by default takes string elements. So whatever value you enter inside this input function, that will be automatically considered as a string, even if it is a number like 4, 5, 6, anything you add, it will be considered as a number. And these operations will fail on string because they are permissible on numbers only. So how we can deal with this scenario? We can restrict our input function to work with either maybe floats or integers. And how we can do that? We can just write one additional function outside this. Like I'm restricting it to use floats right now. So on both sides, I have inserted the brackets associated to this float operation. And if I run this now, you can see it asks user to enter the first number. For instance, I enter 10 as first number, then it is asking for the second number, maybe 2 I have entered. And you can see result for every operation. And this is with decimal point automatically, since I have made it a float by default. So accordingly, the operations internally are executed with a float sequence. So I'm just sharing this code as well in your snippet. Just let me know if we are all on the same page and you are getting the concepts that we are doing here. If anyone is in trouble anywhere, please let me know. You can ping me in the chat box. Are we all good? Students, I'm looking forward for your quick replies, because then only I can understand that you're learning everything. Okay, good. Be active in the chat box also, because otherwise this will be a one-way transaction. We have to be interactive in the session, because that will ensure that whatever I'm telling you, you are getting those points. And please keep on executing them side by side as much as possible. Although you will get these sheets later on also for practice, but still prefer to execute them side by side. So these are your basic arithmetic operation. In the similar manner, we can have some other operations such as comparison operators in Python. And for these comparison operators, we generally get outcome in the form of booleans. We can say here, output in the form of booleans. And what we have as booleans? True and false, that we have discussed already. So when we execute these operations, the output will be true and false. If comparison is true, then of course true will be output, otherwise false will be output. Yes, of course, Himanshu, it can be int also instead of float. We can restrict it as per your choice. You can just write here int instead of float. Both are possible. So the comparison operator we are using here is, for instance, I have x is equal to 5 and y is equal to 2. Just two numbers I'm declaring here. And then I'm using print statement with them. And we'll be using this with different operations. So first I'm taking is, for example, x is less than y. This is my first operation. And with the simple mathematics, we can write it here. with this symbol. X is less than Y. Your simple comparison operator. Similarly, we can add it with others such as X is greater than Y. The symbol will be exactly opposite. Then we can have it probably with less than equal to. So for this, we can write equal to along with this less than statement, and it should be in this format only. First, you have to write the less than symbol, and then you have to write equal to symbol. It should not be opposite, then you may get an error. So this is the accepted format. Similarly, we can have opposite of this, that can be greater than equal to. So for this, simply you have to change the symbol right here. And one more we can add is when you have to just check if X is equal to Y. And for this, now we need double equal to right here. So double equal to here works as a comparison operator. However, this single equal to works as an assignment operator. See this very carefully. We call single equal to as assignment operator. And when we have double equal to, it is a comparison operator, because it is just going to compare your X and Y. And if I run this particular, you can see outcomes in the form of true and false. So whatever we got as true, that will be printed out automatically here. So this is a simple sequence of comparison operator, and I'm sharing the code in the chat. Along with this, we can also have several assignment operators in Python platform. And these assignment operators you can utilize for assigning values directly along with the operation. For instance, again, I'm taking these values only. And inside this, what I'm doing here, first I'm taking the value of X. I'm just printing it as it is. And then I'm executing one operation, plus equal to Y. And after this, I'm printing value of X again and printing value of Y again. See this one very carefully, although it is simple, but beginners need to understand the concept here. First, I'm taking two variables, 5 and 2, saved in X and Y. I'm printing the value of X so that the initial value we can understand. Then I'm using here one operator, one assignment operator, which is add and assign. What we are doing here is I'm adding the values of X and Y, and the result I'm trying to save in X itself. Means X will be updated after this operation, and it will contain the result of addition. Otherwise, when we did this type of addition operation earlier, we used third symbol or third variable to save the result. But here we are saving it in the existing value only. So if I execute this operation, you will see first value of X was printed as 5, but after the operation, new value of X was updated as 7, and the Y stayed as it is, because we are not making any change to Y, but to this X. And this type of operation you can conduct with all your arithmetic operations. You can use here minus sign, you can use multiplication sign, you can use division sign, and whatever you have on the left hand side of these operators, that will be used as your variable to save the result. This is how your different assignment operators will work in combination with your arithmetic operators. So I'm just sharing this code also in the snippet. I hope you will get it easily for the remaining operations also, for subtract and assign, for multiply and assign, for divide and assign. They will all work in the similar pattern. After this, we have another set, logical operators. I hope you all know about gates. You might have studied about AND gate, OR gate, etc. They are widely used by everyone. So the same operations we can conduct in this Python platform also, and there are some reserved keyword for that also. If you check the keyword list on the top, you will find them over there. Here I'm just using them, and as the logical operators, if you have used them in digital electronics also, they work with true and false symbols as your standard operation. So the same I can use here. For instance, I'm declaring X as true, and maybe Y I'm declaring as false. With Boolean declaration, since I'm going to operate on logical things here. So with this, I can operate over X and Y, a simple AND operation. And you can see Python is a very user-friendly language. You will see simple English language syntax for everything. This is your AND operation. You can write simple AND over here to execute. Similarly, we can have OR operation in this format. And one more operation that you will find here is NOT operation. For instance, I'm writing it here in this format. Now, tell me quickly in the chat box, with a common logic, they should all work, or I may have error at any one position with the common digital electronics logic. Is this all fine, or there is some error somewhere in between? A quick update in the chat box. Anyone with the idea if the code is fine or some error is there? Yes, students. So even if you are not able to find it, just give your yes. Okay, great. One response I can see. Third will give an error. Any idea, Himanshu, how this may appear, or what is the reason behind the error over here? Or anyone else wants to report? Be active in the chat, everyone. You just have to use your common logic of digital electronics. This is not something out of your syllabus. We are just using the basics over here. Okay, so no problem. If you are not willing to respond, what we have here, see carefully. When you have a NOT operation in digital electronics, it is executed only on single variable, not on two variables. Because I have written here two variables. Some of you have responded now. Yes, because the operator works only on single variable. So accordingly, I have to write it here since it follows the same logic in Python as well. So how I can write it here? I have to write the operator first, and after that, I can use the variable. Make sure this has to be in the same format. You cannot write the variable first and operator after that. Rather, you have to write the operator first and a variable after that. So this one will work on Y right now. And you can see the answers for each one of them. And you can just compare them with your original AND OR gates, etc., and you will get the same answer. So this is your logical sequence of operators, and I have just shared this in the snippet as well. In the similar manner, we can have one more sequence, which is your identity operators. In case of identity operators, we just try to check whether two variable declarations are equal or not. So just one example of this I'll be using here, because these identity operators are used in a variety of operations while working on Python platform. But just a basic example I have here. For instance, I have A is equal to 5, and then B is equal to 10, and for instance, C is equal to 5 again, and then D is equal to 2. These are my initial declarations. Now I'm just trying to check if A is equal to B. So instead of using those assignment operators or the comparison operators from the top, currently I'm using identity operators that work with these simple English sequences. If I have to check if A and B contain similar value, I can use is operator in between. Similarly, A is not B, for instance, and all of them I can check in this format. And we can run this, and you will see these identity operators also give you outcome in the form of booleans. So accordingly, true and false you will get, such as the value of A and C is same, so we are getting true in the last statement, and A and B are not equal, so that is why we are getting true in the second one also. So in the similar manner, you can test it over any number of sequences. So these are all essential operators you will find in Python platform. I hope these operators are clear for all of you. Just some basic operations with operators we have done using your Python language. You can give me a quick update in the chat box if we are all on the same page and it is clear up to this point. Okay, great. I'm seeing some replies over there. Great. Thank you so much for updating me. And after this, we are going to start with some operations on the strings. Some basic operations on string we are going to do here. And while working on strings, one thing we have already seen that we always write strings inside inverted commas. The single and double inverted commas we can use alternatively. However, triple inverted commas in sequence are utilized for multi-line statements or paragraphs. So those we have already understood. Now I'm using some operations on strings over here. First, I'm declaring one string sequence. For instance, this is hello Python. And now I just need to get a value, or we can say a substring out of this sequence. Here comes one important operation now. Whenever we are storing a string sequence in a variable in Python, the platform gives it automatic indexing. And that indexing can work two ways. They can have positive indexing or they can have negative indexing. Two types of indexes are possible. These indexes are basically, if they will represent you how in the memory each one of these values will be saved, what will be the sequence out there. So in layman language, you can understand it like when we talk about positive indexing, it starts from left to right, the same way as we read any sentence in common terminologies. So you can see here that H will automatically get a 0 index, 0th position while saving in the memory, and so on. It will go up to this last point. So it will be like 0, 1, 2, 3, and so on up to the last point. Ranging from how I told you, left to right. So from here to here, we'll be reading it in sequence. However, in case of negative indexing, we read it from right to left, and it always starts from -1 because we are reading it from here. So how it starts? Right to left. Since -0 doesn't mean anything, so it will not start from 0, rather starts from -1 from the right. So this is how indexes are assigned to these with values, and we'll be using this in the similar pattern throughout your Python platforms. Whenever you will be accessing some arrays, whenever you have to access some vectors, everywhere the indexing work like this. In lists, in tuples, everywhere we'll see in this pattern. So right now, for instance, I just need to see the firstmost element like H from the sequence. So how I can access this? The variable where this sequence is stored, and then within square brackets, I can write the index value. That is currently 0. So it will always start from 0. So we can see it prints H in the output. Now quickly update in the chat box. If I have to write this P, if I need this P in the output, what should be my index value? What I should change here instead of 0 to have this P? Anyone in the chat box quickly? Okay, I get one reply, 5, 6, 6, 6. Okay, so we have some, we can say like combined responses. Most of you say 6. So let me write here 6. Let us see what happens. I'm running this and we get P. So for those who feel that it should be 5, what is the trick here? It will consider the space in between as an index value. So our index will be automatically assigned to this space as well. Depending upon how many spaces you have in between, some indexes will be covered in that as well. So you will just count it from -1, sorry, 1, 0, then 1, 2, 3, 4, 5 will be space, and then 6 comes as your Python P. And now the next question I have is, if I have to access this T with negative indexing, this T with a negative indexing, what I should write here? Just a quick update in the chat. I'm talking about negative indexing right now. Okay, some people are replying that we can write -5. So let us see if we can do it -5. And the output is T, of course. So you are right, because we'll start it from here. See this, everyone carefully, those who are confused. We have one symbol by the end. This exclamation symbol also will get one indexing. That will be -1. Then we will have -2. Then we have -3 for O. Then we have H with -4 and T with -5. That is why with -5, we are getting a T in the output. And along with this, there is one more way. The first we have learned here is indexing. The second thing we need to learn here is slicing operation. Slicing operations are also commonly used with a variety of data types in Python. And how this slicing works. Slicing will help you to get some intermediate values with a set of instances as you update them in the chat, in your code. For instance, I'm writing here print variable, and the sequence I'm writing here is 1 to 4, for instance. And if I execute this one, what we will get in the output, see this very carefully. It starts from 0, then we have 1, then we have 2, 3, and 4. I'm writing it 1 to 4, but getting it up to 3 only. So here we come across a new rule. And what that new rule says, whenever you are using a slicing operation, the end point will be always less than given value. 1 less than given value. So if we have 4 over here, it will give you up to 3. This slicing operation works in the similar pattern everywhere. The starting sequence will be considered as it is, but the ending will be 1 less than the given value. That is why we are getting here ELL only. Now, this will work with positive indexing as well as with negative indexing. You can use slicing operations easily. So now give me a quick update in the chat box. If we just need to extract only Python this P to N sequence by using slicing operation. Any idea how we can do this? What should I write in the slicing operation? I'm sharing this sequence in the chat box also. So if anyone feels that they have not written the entire code, I have shared it in snipper. The task here is get Python. And we have to use slicing sequence for this. Okay, so we are getting some responses. Okay, some people are using positive indexing, some are using negative indexing. This is fine. So let us test some of these options that we have received in the chat. For instance, one I have is -2 to -8. Let us see if it works. So see, this doesn't provide us what we need actually. Maybe we can test something else. We have one positive indexing also, slicing operation also someone has assigned it here. 6 to 12. So this one we are getting as Python. The last one we are able to get as Python with the positive sequence. So this is how you can access the intermediate values. We can try the negative operation for this also, but that I will leave with you as a task. You can try that and definitely it will work easily. You just have to understand the concept. So I'm not doing that. You will try that later on with a negative indexing. And you can just print the values in the similar manner as we have used it earlier. So next to this now, we have just learned some initial indexing and slicing operations on strings. Along with this, we can also have some formatting operations on string. So I'm writing here string formatting operations. And if I execute it over here, for instance, I want to print a sequence that contains my name is %s and age is %d years. This is the sequence and I want to format it in runtime. For instance, generally, whatever we have seen till now, whatever we write inside inverted commas, it is printed as a static sequence. So it should be printed as it is. But what I want is, I want to update some values over here, not within this sequence, but outside this sequence, and they can be taken automatically. So this is a kind of formatting. There are many other types of formattings that you can use with strings, but one of these I'm sharing here. So how we can do this? After this sequence, I can update the percentage sequence. And here, what we can write is, first, I can write, for instance, it requires name first, so that I have written, and maybe is, for example, I'm writing here 40. So it will be taking these values one by one. Let us see. This is automatically formatted based on these values. And there is one more important thing to learn here. When we write %s, it will search for a string value. So first value here should be automatically a string sequence. When we write a %d here, it will search for an integer sequence. So second value, it will automatically get it from the sequence. The same sequence it will try to search here. So second value should be an integer here. And if we write here %f, then it will get it as a float value. So integer will be automatically converted to float, but the string and the number, they must be differentiated very carefully. So if we have it as %f, you will see this is converted to a floating point number automatically. So percentage D and percentage F may work along, but for percentage S, you should precisely have a string value. For instance, if I change the sequence, if I use this over here, and then I try to run it, see, we have an error. Must be a real number, not a string. So this gives you a quick indication. And you can just solve this sequence here. It should be in the same pattern as we have given in the formatting sequence. So I have just updated this sequence in the snipper also. And in your Python platform, it is also possible to play with the string letter case settings we can apply. And for this, we have different options. I'll be using few of them. For instance, we have a text sequence over here. Maybe I can use a quote here. And this is a simple quote I'm using over here. And you will see right now, the first letter here is capital and this A is capital, rest all is available in small letter sequence. And now I'm just trying to format the case of these text sequence. So for this, I can use different operations. First, I'm just changing this text sequence into lowercase. So I can use a method lower along with this text. Similarly, I can use another, we will see the output together. First, I'm updating all the operations. We can also convert all of them into uppercase. One more operation we can try is like, if you need all of them as title case. Most of the case changes that we have in your Microsoft Word, those are possible in your Python sequence also. So we can easily format anything. And this you may find useful when maybe in future you will be designing some websites using your this Python platform where you have to do some quick formatting on the text. So you can do this by using these simple type of operations. We have one more such as swap case. So I'm using these operations. You will find many other also, but just a few I'm using here. Let us see what we get in the output. Okay, I may have one typo over here. So we need capitalize. See, a simple change in the sequence. We were having T capital and A capital, but when I used lowercase sequence, everything is turned into lowercase. Then in case of upper, we have everything in uppercase. Title case with first letter of every word capital. Capitalized sequences, the first letter only will be capital, rest all will be small. And swap case just swaps it opposite way. So the capital will be turned into small and small will be turned into capital. So we can try all these formatting sequences easily on your strings. So let me just know if we are all good up to this. We have learned different primitive data type operations till now. And after this, we can switch to some non-primitive data types. Just give me quick updates if we are fine up to this. Okay, great. Thanks for responding. So this is good. Next, let us go ahead with a new task, that is your non-primitive data types in Python. And in this non-primitive list, what we have is, there are different options that you can find. First, we have list. And what we call, or as a general definition about list you can have is, this is a collection which is ordered and changeable. This is a simple definition of list and allow duplicate entries as well. In case of list, you can do this. Entries, or we can call them members of your list, anything you can call. Similarly, the second you can have is tuple. Tuples are same as list, so some options they will use in the similar manner. We can say these are collections which are ordered, but the difference is unchangeable. You cannot change the values in 5 tuples. You cannot delete them. You cannot insert new values. However, they allow duplicate members. Currently, we are just learning the simple definitions of these, and then we'll be using them in Python programming also. Next, we have sets. In case of set, this again is a collection of elements, but they are unordered and unchangeable. This is the first thing. And also, one more thing is here, they are unindexed as well. In case of list and tuples, you will get indexing for all the elements. The indexing that we have learned already from 0 to the value that ends in the sequence, or it can be negative indexing also, both works fine. But in case of set, they are not indexed. That is why they are unordered also, because indexing basically help you to create ordered sequences of elements. But as sets do not get indexing, so they are unordered elements. However, they cannot be changed, and they do not permit duplicate entries. So if you try to enter similar elements twice in a set, they will just consider one out of them, other will be rejected, and we will see that in the coding also. The last one we can have in sequence is a dictionary, which is again a collection which is ordered, and along with this, it is changeable. That is the second option we will have, and no duplicate members. So these are your simple definitions for all these kinds of primitive data types, and I can share them, these details also in the chat box, so that you can just keep these definitions in your mind. Now let us have some operations on each one of them. I'll just have few basic operations on each one of them. So first we are trying to go ahead with Python list. And inside Python list, first we will learn to create a list. For instance, I'm just creating list 1 over here. I'm giving it the variable name as list 1. And the important thing to know here is your list is always created within square brackets. That will be the representation for list within square brackets always. And a list can contain different types of data elements. For instance, we can have some string values, like I'm entering here few. It can also have integer values such as these, and also it can have floating point numbers like this. So this creates your first list. Let me create one more. For instance, a list can have different types of data elements as well as all similar types of data elements. For instance, I just create a set of number sequences over here. So 2 lists I have created, and we can probably print them also in the same sequence as we have used print commands earlier. So this is your list 1 and list 2. So you can see the first list and second list, and they can be printed in the same sequence. So I'm sharing first of all these 2 lists, and then we'll be doing some operations on these already created lists. So what we have, first thing we need to learn is the same indexing and slicing operation if they can be executed on your list. So how we can do that? For instance, I'm just running here indexing and slicing on your list operations. And for this, from list 1, For instance, I need to get this value, chemistry, from list 1. Just give me a quick idea what I can use as an index value for this. You can tell me positive indexing or negative indexing as well. Currently, we have this comma separation between elements. So they will be individual elements separated by comma. Based on this, just give me a quick update. What should be the index value for this chemistry over here? I'll be updating the same here in the square box. Quick update in the chat box. Any guesses that you have? Right, wrong, just don't worry. Just update in chat box. That will help me to understand if we are all in the right direction or I need to explain more. That is why I'm asking to update in the chat. You can use positive indexing or negative indexing, that is fine, both will work. But what number for this indexing of chemistry I should write here right now? 0, 1, 2, 3, or -1, -2, anything that you feel that will print chemistry from list 1. Okay, I got one response that says 1. Good. So we think that it will give you the right answer. So list 1 with one indexing element will print your chemistry value, since the 0 will get with physics and then 1 will automatically get with chemistry, since it is the positive indexing sequence which starts from 0. You can take it from the negative as well, that will work as well. For instance, now next one I'm taking here is, maybe I need to print this 4, element 4 I need to print with a negative indexing. Just give me a quick update. What negative indexing I should use to print this 4? So list 1 I have to print, and I got the responses that it should be -3. Let us see if I use -3. So yes, we are able to get 4. So this is good to know that you people are in the right phase and we are learning this all as a positive and negative indexing difference. Now, one more thing we will see here is your slicing operation. For instance, I want to use list 2. You can do it on list 1 also, but just for an example, I'm taking list 2 now, and I want to use slicing operation that such that I get values 4 to 6. Notice it carefully. We are using slicing operation, and the value I need to print is 4, 5, 6 from list 2. What should be my slicing sequence, starting and ending sequence for this slicing? A quick update in the chat box. Everyone just be responsive in the chat. Okay, so one response I got is 2 to 5. So let us see 2 to 5 and see what we get is 4, 5, and 6. So definitely good. That's good point, because it will take it from value 0. We are going ahead with 2, 3, 4. Sorry, this is 1, 2, 3, 4, and 5. So 5 will be with 7. But as we know, slicing operation goes with 1 less than the ending value. So that is why we are getting it up to 6, and which is what we need. So this is how your slicing will work. And you can use it again with the negative slicing also. So that is your choice, how you can update it. I'm sharing this indexing and slicing operation also in the snippet window, so you can use it from there. Now, after this, let us try some creative operations with your list. First thing we'll do is, let us update a new entry in your list. We have some existing functions that we can utilize for this purpose. For instance, in order to update a new entry with a index value, first thing we'll try is update with index value. For this, what we can try is, let me first print list1. Let us see what it is initially, because we have already created it. So we'll just use it from there. We are not going to create it again. First, I'm printing the original version of list1. After this, I'm updating a new value into list1. And how I can do this? List1. On the second index value, I'm adding one more value, for example, 2023 at second index value. And after updating this, I'm printing my list again. If I check this out, you can see on this position, we can see a new value right now, because this is updated with the 2 index number, and 2 index number will be right here now. This is 0. This is your 1 and this is your 2. So in this manner, we can add any new element into the list. For instance, we have a list containing name of or roll numbers of all class students. And there is a new enrollment in the class and we want to update that new name into the existing list. So instead of creating a new list, you can simply use the indexing operation to update that new value in the list. That will save your time. Instead of creating new list, you can update it anywhere in between by using the index value. So I have shared this update code in the snipper window also. But now maybe you want to delete certain element from the list. That is also possible. And how you can do this? I'm using, for instance, the same set of operations, but now I'm going to delete the element. And how we can do this? With a reserved keyword, delete, that is represented with DEL. And for instance, I want to delete an element that is positioned at third indexing point. So if I print this, this is your initial list that was updated here. And after this, the new list is updated where 4 is missing, since this was at third indexing point and we have just deleted this particular element. So what we can do here is delete a specific indexing element from list. You are just taking it from the index value. I'm just sharing this code also in the snipper. So after updating this, the next thing that we can try is one important operation. The most of things we have already learned, but one important operation we can see is append operation on list. That is widely used. So if any of you is also preparing for some kind of interviews or maybe some kind of Python based for the learning platforms, there is one common question that is asked in your Python interviews also that we are going to learn right now. We'll learn 3 different operations and each one of them have a different meaning. First of all, I am just starting with append operation. These are some of the most important operations you will see in list. First we have is append operation on list. And for this, first of all, for instance, I'm creating a list over here and the list contains some mixture of elements, just some random values I'm updating here. These are some random values inside my list. Now I want to add one new element into this list 3. What I can do for this is, first I'll pick up this list 3 and then into this I'll use append operation with a dot operator. It will work. List 3 dot append, and inside brackets I have to write the new value. For example, I want to update a name inside. Append this name Zara into list 3 and we can see the updated list. If I run this, you can see this value is updated by the end of existing list. So considering this observation, what we write here, append will insert a new element by the end of existing list. This is the rule we learned for the append by just looking at the observation. Now let us see one more thing over here. For instance, I'm using the similar set of operation. I'm using the same list. I'm not changing it. The initial list I'm using here. And along with this, I'm creating one more list. For example, list 4 I'm creating, and this list maybe contains 2 elements like 333 and 777. These are 2 elements. And now I want to update it with list 4 because I just want to join these 2 lists together. And if I do this, let us see what we get in the updated list. Observe this very carefully. What we have here right now is the initial elements of list 3 are as it is. But then we have the new list updated as a list itself. These values are not updated as individual elements. Here we were having Zara as an individual element. This got a separate indexing as well. In this case, this has a separate indexing also. For instance, if you want to check, we can see it from list 3 minus 1, for example, because this will be the last indexing value we will get. So, okay, this is for list 3. So you can see Zara, this got last indexing value automatically here because we can get it from -1. But here, if I try the same thing in this operation, you will see -1 is getting both these entries together. So what is the limitation of this append operation? Will not add individual elements from the list. Rather, it will update entire new list as a single element over here. So even if we have 10 to 15 different elements in this second list, they will be updated here. But you need, when you have to join 2 lists, most of the time we require that the new list elements also get individual indexing. For this, what we can have is, we have a new operation, that is your extend operation. We are just learning how each one of them is different from one another. Several times you will be asked in the interview that how append and extend operations are different. Now in this case, I'll just take the same sequence that I have used earlier. I'm sharing this sequence in your chat also. And here, instead of append, now I'm using extend operation. Instead of append, I'm using extend operation. And running this, you can see now we have these another list element as individual elements added up into the sequence. And if I check the last indexing position, that will be individually assigned to this 777. This is how your extend will be different from the append. So we can write here individual indexing for updated list elements. And we can see that in the output also. However, you might have observed one thing here, that both your append and extend operations will automatically add the new elements by the end of the sequence. As we can see here, they are automatically inserted by the end of the operation. But maybe in some sequences, you may need to insert values somewhere in the middle, maybe at some specific position in the existing list. So how we can do that? That will be again very simple. Let me take the same set of sequences and let me update this with a new. That is your insert operation. Another important operation you will find in list, and I'm using the same sequence over here. For instance, okay, I'll try this list 1 here again, although we can use it from the top also, but I'm just creating a separate sequence so that you can understand it easily. Now, instead of using extend, I'm using here insert operation. And inside this insert, we can have specific indexing element. For instance, I want to insert this new value at second index position, and then this is the value. First, we have to provide the indexing, then we have to provide the value, and with this, we can get the updated list. You can see here, the last indexing value is also shifted automatically because this is inserted in between. And we can have any update based on this insert operation. Means you can extend your list by any value in between. So these are your 3 important list operation. Let me know if these 3 are clear to everyone, because these are some of the most important operations you will learn. Okay, good. Thank you for responding. Few more operations on list, just 1 or 2 I'll do more, although there are many other possible on your these list sequences, but let us try 1 or 2 more. Everyone just be active in the chat box. One technique we can try is remove an element from the list by value. First thing, we'll try this. And to do this, what we can try is, for instance, I'm again using the same list over here. And from this list, I want to remove one element, which is, for example, this XYZ. And after this, I can print my updated list. A simple remove operation with the exact value that I want to change or remove from the existing list. You can see the updated list now doesn't have this element. So we can call this as operation to remove specific element by value. However, there is one more technique, remove elements from the list by index, that you may also require some time. And in order to do this, what we can try is, you have another operation that we call pop operation. For instance, I'm using the same list here, but instead of remove, now I'm using pop operation. And for instance, I'm writing here 1, because I want to pop out first element based on the indexing sequence. So again, XYZ is taken out, and we can see the updated list here. So this is how you can remove values with different options out there. So I'm sharing both these codes in the snippet as well. You can execute them side by side. So this one is basically by index. So these are all essential operations that you can have on list. And after this, I'm going to start with Python tuples. As we have seen in the definition already, that tuples are almost same as list, but there are few changes that you will see inside. First thing is that tuples cannot be changed. And while writing your tuple sequences, the format also will be different. For example, if I'm creating a tuple sequence, maybe tuple 1, we'll be using parentheses, or we can call them round brackets. In case of list, we were using square brackets. In case of tuples, we always use round brackets, or we call them parentheses. And we can have the same set of elements. Means it can create a combination of different types of elements, or we can have similar type of elements. Both are possible. So I'm just taking these values that we have used from the list, and I'll just update them into different sequence. So tuple 1 we have here, then tuple 2 we have here, and we'll just change the type of bracket that we have for these declarations. We can print them same as list. So tuple 1 and tuple 2 I'm printing here. So you can see they will be saved same as your list, but there will be some difference in the operations that will able to conduct. So whenever you want to create a list of elements that can be changed later on, then we can use the list-based operation with square brackets. But maybe when you want to create a list which should not be modified by anyone, then we can use tuple-based declarations with these round brackets. So that will just ensure that no values can be changed inside, and they will stay as it is right from the beginning to end. So while doing this, the slicing and the indexing operations can be used as it is. For instance, if I use this tuple 1 and I just try to access any value out of this, it will bring you the value by index position. So we can have it here. I'm sharing these tuple declarations with all of you in Snipper, and you can create these tuples and apply different operations that I'm having here. And similarly, we can have slicing operation also. For example, 1 to 3, I'm trying to slice here. So we can see these two values. So exactly same as that of list. We can have slicing and your these indexing operations, both will work similar. But if you try to delete certain element from the list, from these tuples, in list, we have seen that delete option. But if you try the same in case of tuples, maybe I try it with tuple 1 here, and I just try to delete tuple 1 third element. So let us see what we'll get in the output. See, this says tuple object doesn't support item deletion. And you will see this is very easy to understand. Means even the error sequences in Python are very easy to understand. And let me just show you a way to check your errors in Python. There are different ways to check your errors. First of all, you will always get here the line number. If you are writing a code with multiple lines, it will here state clearly that in which line you have error. For instance, currently we have it in the last cell. So it says in the most recent cell. Otherwise, you will have here number line 2, line 3, line 4, wherever is your error. There are different ways to identify errors in Python. Second way, you will have an arrow always indicated towards the line that has error. This is second way. An arrow will be always present wherever you have an error in the sequence. Third thing, in Google Colab, you will also get this red mark below the error prone line. Wherever you have error, this red mark will appear automatically. And fourth technique, you have information about type of error by the end of this error sequence. So it will just help you understand what kind of error you have along with the description. This makes error identification very simple in Python. We also need to learn how we check errors and how we diagnose them. So that is why I'm just showing this to you. 4 techniques to identify errors. First is the red sign you will find here. Second is the line number you will see here. After this, we have the arrow marks pointed to the specific place wherever you have error. And then you have description about the error. So you can just go through these things and you can easily identify or diagnose your error. Currently, we have learned that tuple values or elements cannot be deleted. And also, if you try to insert new values into tuple, that is also not possible. If you try append, insert, etc., they will not work on your tuples. For instance, I use here tuple 1 dot insert operation, and inside this, I try to write index value and this. So if I try to run this, again, we'll get error. That tuple doesn't accept insert operation. However, if you want to delete entire tuple, that is possible. For example, I write here delete tuple 1. So this will work. This will simply delete your tuple 1. And if after this, if you try to print tuple 1, it will say it doesn't exist. So you can see this is not defined because we have already deleted this one. So this is how we can just prove whatever definitions we have learned, that you can have almost all operations on tuple same as list, but it is unchangeable. You cannot insert new elements, you cannot delete any element out of this, or you cannot make any updates into the existing tuples. So just let me know if it is clear about the list and tuples, if you have got the idea about both. Just a quick update in the chat. Okay, great. Thanks for updating in the chat. So the next thing we can see is Python sets. So I'll be just showing you few operations on sets also. The initial definition we have already seen. We have seen that your sets can have unordered sequences and they do not allow any duplicate elements. So let me just update some set sequences. For instance, I have here my set, and sets we write inside these curly brackets. The same we use for dictionaries as well. Inside these curly brackets, you can update your sets. And for instance, I'm just updating some values, some random values inside. You can see these are the values I have inserted. And then I'm trying to print this my set. In the definition, we have seen that sets do not contain duplicate values. If I could have created similar type of list, these elements could be stored as it is, and each one of them will get an individual index values. You can test that also. But in case of set, only one value will be accepted at a time. So if we have 4 2 times, only one will be taken. If we have 7 2 times, only one will be taken. And another important thing, they are not getting index values. So they are just ordered in sequence over here, not ordered in form of indexing, because sets do not have indexing. So we call them unordered pairs, because your index values are the main thing that helps you to create ordered sequence. Such as in case of list and tuples, we could access things from these index positions because they were ordered based on these index elements. But this is not possible in case of sets. So even if you try to access something from sets by using index values, it will not work. It will simply say that this operation is not applicable on your sets. If I create some other kind of set, for example, my set 1, I'm creating here with some string values updated in this pattern. Any random sequence I'm using. And then we are just trying to print this, my set. And here we can see they just got formatted in the form of any random operation because they are not getting ordered index sequences. So they are just updated here randomly. And if I try to add maybe a new value to set, that is possible. But what is the technique? Let us see. My set 1, and I'm updating a new value. I can use add operation for this. Add, and what I'm trying to add is, for example, 8. And then again, I can see my new set. You can see this 8 is updated randomly anywhere because we don't have ordered sequence. So anywhere it can be updated automatically. So let me share these set operations, basic operations with all of you in the snipper also. You can try them. As you might have studied in your mathematics or simple stats also, these set operations can also have union and intersection operations. So I'm not executing them here, but yes, you can have those union intersection operations directly in Python as well. They are even saved with the same name, union and intersection, etc. So you can apply them on any of your set operations out there. So these are your some essential operations on sets. I'm not going in detail with this. Next we have is Python dictionaries. Another important thing you need to learn about your non-primitive data types, Python dictionaries, and we have seen the definition for this, that they can have different key pair values, but they are preferably going to have your, let us see the definition again. We can see the collection of ordered and changeable, but no duplicate members. So let us see how it works. In case of dictionaries, mainly, we are going to have some key pair values. For instance, I'm creating here a list X. It will be also in your curly brackets, same as sets. And key pair values are created like this. We separate this with a colon. On the left side of column, we have key value, and the pair of this is written on the right side of the column. So this is your first element basically, and single element in dictionary contains a key and pair itself. For instance, the second value I'm updating here is 2, and then maybe third. You can have any sequence. It is not like you should have 1, 2, 3 sequence only. You can have any value over here. So this is one random sequence I have created. Similarly, in Y, I am updating few elements like for string, I need to have brackets. I need to have these inverted commas. So this is my key value. And inside this, I'm saving a pair 1. And we can even have a sequence inside this. Sequence in the form of this multiple values. Python and year I'm updating here. And I'm assigning a pair value to these. And for instance, it is first element I have course, and second element I have is maybe year. We can have 1991. We can print X, we can print Y. These are some random dictionaries I'm creating with key pair values. We can have them in any format. You can have mixture of data types, anything we can have. And we can access them with index values also. For instance, from this dictionary 1, I want to access first element. You can see 1. This 1 I'm accessing, and it will present you the pair value, not the key value, because key value it use to store your element. Similarly, from 3, I can get the value 3. Similarly, maybe if I want to use it from Y, and I write here maybe first, let us see what happens. For Y, you will get an error because this doesn't have one element. Rather, we have saved it with this first. So if I try to access it in this format, let us see, you can get this first value. So it means that we are assigning the key values here from the right side, and whatever value we have as a pair to this key, that will be automatically extracted whenever we execute this operation. So I'm sharing both these details in the chat window also, in your snippet window also. You can execute it from there. And these dictionaries can be used to create a big set of descriptions. If we have an entire set of details over here, let me create one example. For instance, we have one dictionary named person. And inside this, I can write different values. I can update one by one different values. First, I'm updating first name. And then the first name I'm assigning is, for instance, this. Second sequence in this name I'm adding is last name. And for example, anything I'm writing in the last name. One more entry I'm making is, we can even create complete descriptions inside dictionaries, and they can store entire details precisely. Age I have saved, and then person, maybe spouse details we want to save. That also we can write here. Names you can update. Then we have, for example, a list of children we want to update. That also we can have, because this will be a list only, since we are trying to update multiple things here. So maybe one by one I can write here different names. So these are different children names I'm updating, and maybe one we can have is like pets held by that person. So that also we can update in the list. And let us see this one in a creative way. For example, pets, the type of pets and name of those pets also we want to update. So I can create a dictionary sequence inside this also. Like we have dog whose name is maybe Fido, and we can have a cat whose name is maybe Catty. So these are all detailed, saved inside this person. And I can just run this and we can see this. So everything is saved inside this person right now. Means you can create complete detailed description of anyone using these dictionaries. One by one, every element will be saved, and you can even update these elements anytime. Maybe when you are creating this sequence for a set of employees in your company, so we can have this information stored in the form of dictionaries. And maybe after like few months, you get some new details about this person. Like maybe you want to update his current salary, maybe you want to update his current position. You can update those details instantly. For instance, we can have here like person new entry I want to make. And inside this, the first element I'm updating is the department of the person. So maybe he's working in finance department, and current salary of the person is maybe like 45,000 or 54,000 I have updated here. So these elements we can add into your existing list. Person, update, and what we have to update is the new values that we have stored here. So after this, if I run this value, we can have new entries inside person. You can see after pets now, even the department is added and salary is also added, since I have updated new key pair values into the existing dictionary. So let me share this update also with you all. You can check it with the person itself. And even if you want to access a specific sequence out of this, for example, instead of checking all elements, I just want to know the children details of this person. So I'll just write this element value and we can see the output that this person has these children names. So this will quickly help you to create your outcome sequences out there. So let me know if it is clear up to all these different types of data. We have learned primitive data, we have learned non-primitive data types also. So let me know just if all this is clear. Okay, thank you very much for the updates. After this also, we are left with several operations that we can have on Python, such as we will be learning decision-making statements, flow control statements, or we can have loops also. So the function creation also we will learn. So that will be a small portion that we can discuss tomorrow in continuation to this session.